Hello everyone and welcome back to our channel. As you may know, this is my third video on this channel and I am beyond excited to share this milestone with you. Today is extra special because we are diving headfirst into a brand new series of the Terraform. Here we'll be exploring everything to know about Terraform, the powerful infrastructure as code tool that's been transforming the way we manage and deploy our resources in the cloud. So make sure to hit the subscribe button and turn on the notification bell so you won't miss any upcoming video in this series. Alright, let's jump right into the first episode of our Terraform series. Okay, let's start journey on Terraform by understanding first the flow of traditional IT workflow and how application dev cycle works in traditional IT sense. First thing is business always creates requirement, a very high level requirement. That is features needs to be added in the application. After that BA, business analyst comes into picture who converts requirement into high level technical details. Once that is done, then cloud architect or any senior technical person create infrastructure design that what are the resource you require for provisioning inside the cloud or data center. After that, if you require more hardware, definitely you need to contact procurement team. Buying new hardware may takes from weeks to months because you are running your application in your own data center. Then comes infrastructure team who will actually going to provision this infrastructure. Afterwards, development team will be handed over to start working on application. Now, this flow has very slow app deployment. It is expensive and scaling resource is the main issue because it is not like public cloud which is highly elastic in nature. For any resource provisioning, it may take weeks and months as well. Here, lots of teams are involved in current life cycle, so definitely manual error will be involved. So to overcome this issue, public cloud providers are the best solution. So there are so many public clouds, but we have three majors: AWS, GCP, Azure. In this video series, we'll focus on infrastructure provisioning in GCP using Terraform. In cloud, the resource provisioning will be very fast from months to weeks. Sometimes it is just matter of couple of days if you have budget approval in place for your project. Public cloud provider manages everything for you. Now the question is how you are going to interact with cloud. One option is through website or you can say cloud console through which we can interact with. Compared to traditional infrastructure provisioning, this is definitely much better solution. Within matter of few clicks, you can provide, let's say, VM in the cloud. But it is good enough if you are managing a limited resource. Let's say you are just managing 5 VM. That is good enough. But let's say if you want to manage thousands of resources, then this click-based approach will not be a good solution. So there is another way to interact with public cloud with programmatic way like API. You write your code in Python or Java or any shell scripting language. Public clouds provides SDK in all majority language to interact with their cloud. So the issue is different team write different script for this resource provisioning. Let's say for GCP we have all the multiple language SDK available in the GCP. Hence there is no unique approach. Different team try to solve same problem but with different way. So we need some unifying approach which solves a problem. And there comes option available like Docker, Puppet, Ansible, Terraform, etc. We are going to focus here on Terraform. So this is the basically journey from traditional IT workflow to the cloud, and inside the cloud how you are going to interact for resource provisioning with one of the hot tool currently, Terraform. All right. So now you are going to learn IAC, infrastructure as code. Here we are provisioning resource as code in public cloud. So either you create, let's say, Python script or shell script for creating VM. That is nothing but you are creating infrastructure as code only. But writing and maintaining such code which you have written in Python or shell script will be a very much tedious task. Let's take example to understand in more details. Let's say you are gonna create some kind of VM inside Google Cloud Platform. So you write a script inside shell script like create network, wait for above steps to finish, provision subnet, create firewall rule, again wait for above steps to finish. After that, create compute engine instance with all the parameter which has been created. So maintaining this type of code is a tedious task, and there comes Terraform, a unique approach to interact with the multiple cloud providers. Here if you see on the right side, there are lots of things Terraform will take care, and it has its own HashiCorp programming language where in a very neat fashion you will write a code which manages everything like creating network, subnet, firewall, its dependency between the two different resources. It will wait for one resource to complete before start provisioning next resource. So everything you do not need to take care. And as its name suggests, HashiCorp configuration language HCL. Here you just need to provide a configuration, and with those configuration it will create resource in the public cloud. So Terraform, we have shown just one single example how we can write the code if you see on the right side. Now let's get in a much more details about what Terraform is, and slowly we move towards a complete hands-on and complete picture on Terraform. So Terraform is one of the most popular tool available in the market for infrastructure provisioning. It is completely open source and free of cost. It is being developed by HashiCorp organization. Now through this Terraform, it's a quick and easy way to get started with just one binary file. Simple, just one binary file and you can good to go with Terraform. You can master HashiCorp configuration language in a very short span of time. So for different cloud vendors like AWS, GCP, Azure, you don't have to write code differently. Once you master SCL, you can write code for anywhere or any vendor. Terraform has multiple providers like AWS, GCP, Azure, and many more are available. And this HashiCorp organization works closely with these major cloud vendors to add more and more advanced feature inside HashiCorp programming language and provider. Now, Terraform is idempotent. What does it mean here? Let's say you have written Python code shell script to create some VM inside GCP. You run 3 times your script, so definitely 3 resource will be created. Therefore, it will cost you 3 times. So maybe you will get even fired also after creating 3 resource. Instead, you just need one single resource only for your app deployment. Now let's say equivalent code you have written in HCL script for Terraform. You run 3 times. Now this is the intelligent part here with Terraform state maintenance. It will only going to create one resource even if you run script 3 times. So definitely it will not cost you 3 times. Now there are lots of native tools are available inside public cloud for creating infrastructure provisioning. Like for Azure, we have Azure Template Manager. For Google, Deployment Manager. For AWS, Cloud Formation is available. These are all cloud native solution. So whatever you learn, let's say Deployment Manager for Google Cloud will not be applicable for AWS Cloud Formation. So there is no unifying common approach when you let's say shift from Azure to AWS or AWS to GCP or GCP to Azure for infrastructure provisioning. Hence there comes Terraform. It is cloud agnostic. It is vendor independent with multiple providers available. Like we have providers available for AWS, providers are available for GCP, providers are available for Azure, and many more are available. Through these multiple providers, you can create resource with HashiCorp programming language with unique approach. Okay everyone, this is the basic idea about Terraform. So Terraform is not cloud native solution, it is cloud agnostic solution. Now in this slide, how we'll see how we can install Terraform. So Terraform is available for all major operating system, for Mac, for Windows, Linux, Solaris, etc. Throughout this course, we are gonna use Windows. But people who have another operating system, don't worry, the code always remains same. With respect to your own operating system, you can download from its official website. I have shared the link. You can go to terraform.io/download link or simply type Terraform download in your Google homepage. Download binary file, unzip it and export path variable. For window, we'll see how to set path variable. For Linux, simple follow these particular steps whatever I have given the command. After that, once done, verify with Terraform version command. Next, you can use or download any editor tool by your choice for writing our code. In this series, I will use VS Code editor. So, we'll suggest you the same. Okay. So, now let me go to the browser and let's first download Terraform binary. Okay. So, we can search for Terraform download here. Just go to very first link. Currently, I am Windows machine, so I am gonna download this. So 64-bit operating system. Okay, just click on download. It is close to around 30-32. Yeah, it is downloaded. Okay, now go to downloaded folder. We have to extract it. Okay, just simply unzip it, extract. So just make it very simple. Okay, extract. So alright. So inside this Terraform, if you see, there is no much file, only one single binary file. So after that, we need to set the path variable. So copy this path where you have binary situated. Search for environment variable, edit environment variable. We have to edit the path. Okay. Now go to path, edit it, click on new, paste the path whichever you have copied. So this is the path where my Terraform binary is situated. Okay. So now press OK. Okay. Okay. Now what I have to do, we have to check the Terraform version. Okay. So just go to command prompt. Now, okay. So just type Terraform version. So we have already installed and it is showing Terraform version 1.5.3. So throughout this course, we'll be using this version only. Okay. Now this is about Terraform installation. Next is editor. So I have already installed this Visual Studio Code. If you see here, I have already installed this Visual Studio Code in my machine. So I will just gonna use this editor. As I told, you can always use your own favorite editor. Okay everyone. So this completes our first video in Terraform series. In next video, we'll get our hands dirty by creating first Terraform file. We'll be learning Terraform init, plan, apply, what is Terraform lifecycle, Terraform workflow, variable, states, providers, etc. So see you in the next video and stay tuned and keep learning.